Hello, today we will learn about group 18 as the introduction to chemical bonding and also how group 18 become a very stable element. Group 18 is called noble gases. The element of this group 18 is inert. Yeah, basically all the elements belongs to this group 18 are inert or unreactive. The inert properties because of the full electron configuration. Usually the orbital s and p are completely filled. The member of this group are helium, neon, argon, krypton, xenon, radon, and oganesson. The discovery of noble gases, actually they are very hard to find because they are unreactive. They are not react with other element. So this stability because of they have full valence electron shells making them stable, then they are not involved in many reactions. The discovery process involving isolating these gases from the air, and then they are pressurized and liquefied. Then we use fractional distillation to separate those gases. Okay, these are the key figures in the discovery. There are Lord Rayleigh, William Ramsay, who isolated argon, and also Ramsay and Maurice Travers, who discovered neon, krypton, and xenon. The discovery timelines and methods is like this. So argon in 1894, basically Rayleigh and Ramsay discovered argon by removing all other gases from the sample of air. So the method of collecting, they just pressurize the gas, and then they use fractional distillation to separate the gas based on the boiling points. And there is a left, if let's say the oxygen is removed, the nitrogen is removed, and let's say the other gases like carbon dioxide is removed, they have a small amount of gases left behind. So they call it argon after the Greek word lazy because it's so unreactive. Then helium is observed by astronomer called Pierre Janssen in 1868 as a yellow line in sun spectrum. And then later on it's named Dietrich-Fraunhofer line by Norman Lockyer. And then it can be isolated later on Earth in 1895. And maybe the last, neon, krypton, and xenon is isolated by Ramsay and Maurice Travers in 1898, yeah, by fractionally much further fractional distilling liquefied air. And then the last one, radon, in 1900 is discovered by Frederick Dorn, who observed that radium compounds emitted a radioactive gas called radium emanation. Okay, let's take a look on the electron configuration of this group 18. Helium has 2 electrons in its the only and also the valence electron, which is 1s orbital. There are only 2 electrons on that. And neon has 8 electrons on the valence electron, as well as argon, krypton, xenon, radon, and oganesson. So because there are 2 electrons and 8 electrons, by the way, 2 electrons is special only for helium, and the other gases is forming 8 electron valence configuration. So it's called duplet for helium because it contains only 2 valence electron, and for the rest is called octet because it has 8 valence electrons on their last orbital. Then, because of this stability, the other element will try to copy this stability by achieving their octet rule. The first method is by losing their electrons. This is special for metals. Then gaining electrons. This is special for non-metals element. And also sharing electron if it is the bonding between non-metals element. Okay, maybe that's all for this part of explanation. See you on the other slide.